Hello everyone, welcome back to my channel. So in this video we'll try to see an application of the Cauchy Schwarz inequality. So this problem actually came it is from the shortlist problems of IMO. So in 1993. So let us see the problem. So let A, B, C, D be positive real numbers. Then prove that A divided by B plus 2C plus 3D plus B divided by C plus 2D plus 3A, C divided by D plus 2A plus 3B, and the final term is D divided by A plus 2B plus 3C. So this is bigger than equals to 2 by 3. So this is the inequality we have to prove. So let us first observe the problem. So here the thing is, you can see that the denominators are cyclical in manner. So it's 1, 2, 3. Everywhere it's 1, 2, 3, and the terms A, B, C, D are occurring in a cyclical manner. So here it's A, B, C, D, B, C, D, A, C, D, A, B, and last term is D, A, B, C. So this is a cyclical way of writing the thing. Now, so the idea is to use the Cauchy Schwarz inequality. So as I told in the previous video, the Cauchy Schwarz inequality, you have to identify the two sets. So from here it is evident that we have to choose 4 element sets, 4 element sets. So now the only work we have to do is we have to identify the elements of that set, right? So the thing is, if we have this quantity in the denominator, we cannot do much thing. So if we go back to the Cauchy Schwarz inequality, I have a summation of AI bi, right? So the thing is, main aim will be to somehow to cancel the denominator. So that is the main aim. And also I have AI square and bi square. So this term should come as summation of suppose AI square. So that also I have to keep it in mind. So if I choose, so let us see the proof. So let us choose two things. So choose A1 as, or rather let us say A1 square as A by this thing as A1. And similarly you can choose A2 square, A3 square and A4 square respectively. So this will be A2 square, this is A3 square, and this is A4 square. Now let us see what we have to adjust. So if I want to, so this implies, so A1 is nothing but root over of A and root over of B plus 2C plus 3D. So now since it is given that ABCD are positive real numbers, so there is no problem in that. So A1 is there. So now, yes. So now what should I choose? B1 such that if I product A1 B1, the denominator gets cancelled. So at least I want B plus 2C plus 3D, so that when I do the product, this gets cancelled. But if you remember, A1 B1 square, it is not A1 B1 square, it is just product of summation of AI BI, right? So to adjust that, I have to multiply with root A also, so that I get A. Okay, so now this is my A1 and B1. So similarly, I can choose all my b's, so that is b2 will be root b root over of c plus 2d plus 3a, b3 will be root over of c d plus 2a plus 3b, and finally b4 will be root over of d times root over of a plus 2b plus 3c. So now once I have chosen my sets, so these are the two sets, a1, a2, a3 and a4, and the second set is b1, b2, b3 and b4. Now to apply the Cauchy Schwarz inequality. So now you can see that if I do a1 b1, then I get a, a2 b2, then I get b, and so on. So summation ai bi, so this whole square is less than equals to summation of ai square times summation of bi square. So this is the Cauchy Schwarz inequality. This is the Cauchy Schwarz inequality. Now let us substitute. So this is nothing but a plus b plus c plus d whole square, and this is summation of ai square is nothing but this term. So maybe we can denote something. So we can say that this is equals to some s. So here we have s, and let us see what is bi square, what is that. So that is nothing but a times b plus 2c plus 3d plus b times c plus 2d plus 3a, then c times d plus 2a plus 3b, and the final term is d times a plus 2b plus 3c. So this is the summation of bi square. Now let us see if we can simplify to and get some results. So I have a plus b plus c plus d whole square, that is less than equals to s times. Now inside you can see that ab I have here I have ab, and nowhere else, right? So that will be 4ab. So similarly you can take anything. So cd, and one more cd will occur here, d and 3c, so it will be 4. So if you take two terms out of 4 terms, that is 4, choose 2, that is 6 ways you can choose 2 terms, right? And each of them is occurring 4 times. So what I have is 4 ab plus ac ad bc plus bd plus cd. So this is the simplification. Okay, so now we have to find some way to use this and this together and get that what we have to bring 2 by 3, right? So okay, let me write down. So what I have is so 4 times ab plus ac plus ad plus bc plus bd plus cd, and a plus b plus c plus d whole square, that is less than equals to s, right? So if I can show that this part is greater than equals to 2 by 3, then we are done, right? So this means, so let me write down, or maybe you can copy it. So this part, if we can show it is greater than equals to 2 by 3, then we are done, right? Then we can just compare these two things. So let us see what we have to show. So we multiply, we cross multiply, and we get 3 times of whole square is greater than equals to 8 times of these 6 terms. We're not writing all the terms, you can understand. Now just I think expanding will help and certain terms will cancel out. So here I have 3 times a square plus b square plus c square plus d square and 6 times of all these terms. So when I bring the 8 on other side, so I have only left with minus 2 times of these terms. So I think now it is easy. So it will, you can say that is a minus b whole square. We can take 1a square, 1b square and 2ab from other things. So here you can see we'll get all these terms. B minus c whole square, b minus d whole square, c minus d whole square. So this is greater than or equals to 0. So this one was a question mark. So because this we don't know, this we don't know, but now it is true. But this is true. So since all of them are square quantities, so it will be greater than or equals to 0. So hence, so if we compare these two inequalities, we have our result. Yes, what we have determined, it is greater than or equals to 2 by 3. Yes, so I think the explanation is clear. So I think this is a very nice problem where you can apply the Cauchy Schwarz inequality. So again, the main thing is to identify the two sets on which you have to apply the Cauchy Schwarz inequality. So hope you enjoyed the video. Please like and maybe you can express your some views through comments and subscribe the channel for more such videos. Bye.